Thought I would take a look at the last question on the Chapter 7 homework number 22. A couple people have asked about this, so I thought I'd go ahead and make a quick video. Basically, it's looking for proportions, sampling distribution for proportions. And so here we have the market research firm conducts telephone surveys with a 40% historical response rate. What's the probability that a new sample of 400 telephone numbers, at least 150 individuals will actually respond to the questions? In other words, what's the probability the sample proportion will be at least 150 divided by 400, which is 0.375. Calculate the probability to 4 decimals. So I also up here have the z-table, which we'll need in a little bit since we're solving it by hand. So the first thing I'm going to do when I get one of these problems is I'm actually going to try to draw the picture. So here is how the picture should look. Sampling distributions, by their nature, follow a normal distribution, which that looks horrible, probably because my hand is badly sprained from a bike accident, but we'll go with it anyway. So it follows a normal distribution, use your imagination, with a mean of the historical, which is 0.4. So then the question we're trying to answer is, what's the probability that at least, so more than, 0.375 proportion will answer. So that would be somewhere over here, right? 0.3. Again, sorry for my handwriting. So I'm interested in what is that probability. So it's obviously something bigger than 0.5 because everything to the right of 0.4 would be 0.5. So it's something bigger than 0.5, and it's obviously something less than 1.0 because that would be the entire area under the curve. So we're asking, what's the area under the curve to the right of 0.375? So in order to answer that, we need to calculate a z-score, but before we can calculate a z-score, we need to calculate sigma sub p bar. So we have sigma sub p bar, and if you look at the formula in the book, I forget exactly which page it's on, it is p times the quantity 1 minus p, all over little n, which is the sample size. Take the square root of the whole thing. So square root of 0.4, that's p. 1 minus that is 0.6, which you should know. And little n was 400 in our case. So that gives me a square root of 0.0006, which is approximately, because we're going to be doing a little bit of rounding here, 0.02449. So what does that tell me? This number indicates how fat the tails are, how much it's dispersed, right? So it's a measure of dispersion, whereas the mean is a measure of central tendency. So the two things you need for distribution, central tendency, and dispersion. So this tells me how fat the tails are. It doesn't look very fat to me based off of this. It's 2.5% off of 40%, so probably not that bad. So now since we have the sigma sub p bar, we can calculate the z-score. So let's try to do that. So to get to the z-score, remember to calculate the z-score. Z is x, which in our case is 0.375, minus mu, which is, or in our case, p, right, 0.4, all over sigma sub p bar, which we just calculated, 0.02449, and that gives us approximately negative 1.02. So this is our z-score. Right? So we want to look up negative 1.02 in the z-table. Before we go look at the z-table again, let's just remind ourselves what the picture is I drew. Ooh, took the whole thing. Sorry about that. Right? It looks like that. Alright, so let's go look at the z-table. So here's the z-table. We're looking for negative 1.02. So I come down this column over here, right? So it's the intersection of the row and the column. We get 0.1539. Now, that is not the answer, because if you look at the picture, 0.1539 is the area in the shaded blue portion right here. My picture was this part over here in the white, right? So I want the white part, not this. This is 0.1539. So what is this? Simply 1 minus the blue part, right? So for us, it'll be the probability of P bar being greater than or equal to 0.375 is equal to 1 minus 0.1539, I think it was, which is the same thing as 0.8461. Right? So that should make some kind of intuitive sense as well. It's bigger than 0.5, smaller than 1. So now we know that it's about an 84% chance, 85% chance, that we will get a response rate of 0.375. Hopefully that helps you with that question.